Imagine building something that doesn't get weaker over time, but instead becomes stronger. Stronger year after year, century after century. It sounds impossible, and yet it already exists. Ancient structures built over 2,000 years ago are still standing today. Not just standing, but resisting waves, storms, and time itself. And the material behind them may be something we still don't fully understand. Across the Mediterranean coast, ancient Roman harbors still remain. Massive concrete structures exposed to seawater for centuries. In modern engineering, salt water is destructive. It corrodes materials, weakens foundations, and breaks down structures over time. But Roman concrete behaves differently. Instead of breaking down, it appears to grow stronger. And that is what caught the attention of scientists. For decades, engineers studied these ancient structures, trying to understand how they survived so long. Because modern concrete rarely lasts more than 100 years in harsh conditions, but Roman structures have lasted over 2,000 years. Without modern technology, without advanced tools, and without the formulas we use today. So the question became, what did they know that we don't?
Fact trials.
At first, researchers believed it was just good craftsmanship, careful building techniques, strong design, and favorable conditions. But that explanation wasn't enough, because even the material itself was different. When scientists analyzed samples, they discovered something unusual. Tiny white chunks embedded inside the concrete. At first, they were thought to be flaws, imperfections left behind during mixing. But later, scientists realized they were the key. These white fragments are known as lime clasts, and they behave in a very unexpected way. When cracks begin to form and water enters the material, these fragments react chemically. They dissolve and then recrystallize, filling the cracks from the inside. In other words, the concrete heals itself. This process is called self-healing concrete, and it's something modern engineers are only beginning to develop. But the Romans may have already mastered it. Without advanced chemistry, without modern science, just through observation, experimentation, and experience, they created a material that adapts and repairs itself over time. But that's not the only surprising detail. Roman concrete was often mixed using volcanic ash, a material rich in reactive minerals. When combined with seawater, it triggers long-term chemical reactions. These reactions form new minerals inside the concrete, making it stronger over time. Not weaker, but stronger. This completely challenges how we think about construction, because modern materials are designed to resist damage. But Roman concrete embraces interaction with the environment. It changes, evolves, and improves over time, almost like a living material, responding to its surroundings, adapting instead of degrading. So why did we lose this knowledge? Why don't we build like this today? Some researchers believe the exact methods were never fully written down. Others think the knowledge was gradually forgotten as building techniques changed. Over centuries, new materials replaced old ones, and the original formulas were lost. Today, scientists are trying to recreate this ancient concrete, studying its composition, testing its behavior, trying to unlock its secrets, because if we succeed, it could transform modern construction. Stronger buildings, longer lasting infrastructure, and materials that repair themselves naturally. But even now, we don't fully understand it. We know how it behaves, but not every detail of how it was created. There are still variables, still unknowns, still missing pieces in the puzzle. And that is what makes it so fascinating. Because this isn't just about concrete, it's about knowledge. Knowledge that existed thousands of years ago and may have been lost over time. It reminds us that ancient civilizations were not as simple as we once believed, that they understood materials, nature, and engineering in ways we are only beginning to rediscover. So the real question is, how did the Romans discover something that we are only now starting to understand?